Hello, everyone. My name is Eden, and I am the founder and CEO here at Mobot. Uh, I'm excited to have the opportunity to be connecting with all of you today here at the Mobile DevOps Summit, and having the chance to share some of the experiences and ideas that our team has learned from building a mobile testing toolkit with some of the engineering, product, and QA teams that we work with. So our company has a focus. One moment. Hi, everyone. Sorry about the slight delay there. I think we're up and running now. So yeah, excited to have the chance to connect with you today. At Mobot, what we do is we build mechanical robots to automate mobile app QA. And so the reason that we're here to discuss mobile testing is because I've learned a lot about working at different engineering companies and how there's a lot of different QA strategies that can be leveraged across different tech stacks. And so a little bit about me before I jump into the presentation. I started my career working at a company called Palantir. And so at Palantir, what we did was we built data backends for web front ends. And so a lot of engineers would write their own automation. They would be able to build these automated tests using Selenium and Cypress, and it was easy peasy. But then what I noticed when I transitioned into a role at a company called Butterfly Network is they were building a portable ultrasound probe that would plug into an iPhone. And when you use a platform that now has all of these different integration points, you have the firmware, you have the hardware, you have the API, you have the cloud web app, you have the mobile app itself. There's an iPad OS mobile app, there's a iOS mobile app, there is a Android and sometimes an Android tablet mobile app as well. There were all of these moving pieces. And so what I ended up struggling with a lot when I was building out a product development process was it was actually really challenging to do automated testing. And so what would end up happening is the engineers wouldn't have enough automation test coverage, and we'd end up having to do a lot of manual testing. But then as we designed those manual test cases, we would often try to optimize for kind of the ideal scenarios, and kind of what would save the most time as opposed to what would actually be realistic. And so part of the goal of this presentation here today is to just put together an updated checklist about what are the kinds of test cases, especially in this world where a lot of engineering teams are building products that are increasingly physical. We have end users that are using things on the go. There's all of these different devices that consumers can choose from. It's not just, two different phones and it's pretty simple to test. There's all these different variables, especially if you add Samsung, LG, Motorola, different flavors of Android, the manufacturers that are also building their own variations of the Android operating system on top. And then you have different versions of iOS that run on old and new hardware with different screen sizes. And there are Bluetooth peripherals that get connected, IoT devices, medical devices, all sorts of self-checkout kiosks, and smart wearables that are also being incorporated into the mix. And so really one of the biggest observations was just this kind of testing is getting really, really, really hard to do only with software, only with traditional testing frameworks. And so a holistic, balanced approach to doing mobile QA in 2022 involves a certain set of tests that will run in the cloud on every pull request. But there is also a suite of other tests that involve real device testing, automation, manual testing, and exploratory testing that can be covered in order to really build that out today. And so the way that I've kind of observed the testing pyramid really evolving over time is, of course, at the very bottom of the testing pyramid, you have your unit tests. You should be running them on every code PR. You should be running them on every pull request, on every commit. These are tests that engineers should be empowered to write themselves. That's the standard best practices and has been that way for the last decade or so. Then there's also integration tests that are on top of that that will generally run as a part of a sanity or smoke test. These can also run on every pull request or on some kind of nightly build that's put together by engineering teams. And that will essentially involve sometimes talking to the API. Sometimes it is the native app that's integrating with the API. Sometimes it might be with a hardware tool that's running in a rack. There's all sorts of different solutions there, but there should be standard integration tests that are built into an automation infrastructure. But as you move up into the farther and farther up into the testing pyramid, this is kind of where it's gotten really challenging in the last 3 to 5 years. You have UI testing frameworks like Espresso, Appium, XUI, and other tools out there that have made it possible for native iOS and Android engineers to build these tests. They have to be constantly maintained. As your UI is constantly changing, it can sometimes be challenging to also keep these tests up to date. Sometimes it ends up being a balance of, do you spend that time building a product feature, or do you spend that time actually writing a test to support a product feature that is experimental that is changing? And so one of the challenges that a lot of engineers are also encountering is that if they're building a cross-platform app, like Detox or Flutter to be able to support React Native testing and Flutter testing, that can sometimes be challenging to write enough robust UI tests to support all the different use cases. And so what we really see happening is that if you look at sort of the proportions in this graphic, UI tests end up taking a smaller proportion of the entire testing coverage than they actually should. And then what ends up happening is because you don't have enough test coverage, the manual testing portion that engineering, product, and QA teams are then tasked with is that they ultimately need to do more of that manual testing. This can take many days, especially if there are multiple devices involved, especially if you have physical devices that are involved and you need to manage different OS versions, different device models. You're also doing complex physical real world test cases. And then, of course, another opportunity that's really helpful is to, once the code has been released into production, there is value to also making sure that the end user experience at the production side is actually also stable. Historically, it has been difficult to write production monitoring tests and instrument them on the front end. But what we'd really like to see happen more and more over the next few years is developing tools that will support more observability and production monitoring. And that's part of what our company does as well. And so what we've observed is that results are most accurate when they're executed on real devices. So there is a time and place to use tools that involve virtualized or emulators or cloud device farms. But the power of doing physical testing is that you will be able to catch test cases and bugs that historically have been missing. And so really, when we do a full inventory of all the different kinds of things that a user can do with an iOS or Android application in 2022, there is no longer this assumption that a user is only using your app while it's open. There is the assumption that your app may be open in the background and still needs to be ready to deploy push notifications. It needs to be able to accept interruptions. It needs to be able to communicate with other devices or upload data into the cloud in the background. And when it's foregrounded, different behaviors should occur. And so we've put together this list here that really encompasses all of the different ways that engineering teams are looking to reinforce physical coverage on real devices. So like I mentioned earlier, a lot of engineering teams already have their basics, right? The background, the app is foregrounded and they have sort of core UI workflows. And so really kind of the remaining big chunk of manual testing that needs to be automated here is all of these test cases that you see here that involve flipping back and forth between device settings, changing accessibility settings or location services, or switching to a different application such as the device settings app or the Messages app, or even a mail app to actually get a two-factor authentication code, or using the authentication SDK for Facebook, Google, Instagram, all of those other third-party social media networks. There are all of these different complex parts that have to be covered because these are actually core everyday use cases that a lot of engineers need to be able to design for consumers. And so as we move into this world where more and more of those test cases are needing to be covered, a lot of engineering teams are building out these test cases, but running them manually. And so that's really the big opportunity that we're really thinking a lot about with our team here at Mobot, especially because iOS 16 just came out a couple months ago, for example. So the way that home screen widgets and dynamic island and live notifications or notifications in a certain context, the way that that information is then persisted to the user has evolved. And so it's really important when we think about, okay, what are all the different possible ways that testing can occur? How do you not only think about the cookie cutter cases and only be designing for certain test cases that are easy to code, but how do you actually build this holistic strategy where we're using things the way that a human is going to be using them? And so ultimately, that's really the opportunity that our team is tackling and thinking a lot about at Mobot as we work with a lot of the engineering teams that are really focused on improving mobile QA. And so when we think about how test coverage should be evolving throughout the software development lifecycle every single sprint, we've noticed some trends with some of the teams that we've worked with. As I was mentioning before, you should probably have 20% plus unit test coverage on your code that's fully automated on every single pull request. You probably also have some UI automation tests that are running on every pull request, also running nightly, if possible, that will help to kind of just make sure that the core user workflows are working. However, one of the opportunities that's still missing is the remaining sort of 50, 60% of test cases that were on the checklist from the previous slide. Sometimes it can be challenging to do all of those tests consistently. To be able to manually run them repeatedly every single night on a regular basis, it generates a lot of data. It is quite a significant workload. And so that's really what our goal here is, to try and think about ways that we can streamline this process. And so the other thing is also, of course, immediately prior to every release, we want to be able to support engineering teams to run a full regression test suite that's fully automated on real devices every single time. So this can be a weekly or a bi-weekly sprint. And then once that test is actually deployed, or once that release is actually deployed into production, there is also value to doing production monitoring and running some regression tests on just actually the top 20% of the app that's business critical, and also any growth campaigns. So that can be deep links, notifications, app store links to download an app, and making sure that a deferred deep link actually works end to end. This is kind of what we see to be the ideal test coverage, spanning different phases of the software development lifecycle and during the sprint. You're not going to get 100% coverage via unit tests. There is a time and place to be using simulated devices. There's a time and place to then pull in real devices and exploratory testing and production monitoring and be automating on real devices. And so this really does help with just reducing the number of bugs that might be encountered by users in these real world scenarios. And of course, will reduce the number of hot fixes, app store rejections that are going to occur, and just really reduce the burden on your product development process. And so that's a lot of what we've really focused on with our company called Mobot. What we do at Mobot is we are providing QA regression testing as a service, where we use real mechanical robots to automate all of those tests that you saw on that checklist that have been just historically really challenging to cover by existing solutions. We think that it's going to be easier to just do those tests with a robot, and because fundamentally, our guiding thesis for Mobot is that we want to actually test things the way that humans are using them. And so we combine the best of our robotic technology with humans that are overseeing the execution of these tests on the robots, and we can parallelize and scale these tests on real iOS and Android devices and tablets. And then this allows engineering teams that we work with to then reduce their manual testing workload so that they can focus on more exploratory testing. They can focus on triaging the results that are found by Mobot, and really just focusing on kind of the strategy piece of how do we get to full coverage, realistic testing scenarios. And so everything that was shown on that slide with the different viable everyday testing scenarios, an engineering team and a QA team need to kind of focus on building that strategy and defining what those are. And that does involve product research. It does involve customer and end user empathy. And so our goal is to really empower those teams to focus on that rather than mashing buttons on a touchscreen. And so, Sandra, I would like to play a video. I want to be able to show everyone what Mobot actually does. And so here you can essentially have a video of our robot actually running a test on a fintech app here. And so the robot is kind of navigating through the initial onboarding flow. This is an actual physical iOS device that's in our inventory in our New York City office. We have a fleet of these robots that are ready to run tests. The tests are pre-programmed regression tests. And essentially, we've trained the robot to respond to UI components that are on the screen. And so where this really comes in handy is for situations that involve complex out-of-app interactions. So here's a pretty classic flow. It's a phone verification flow. You can see we're requesting a text message to be sent. So now after that push notification is received with the text, we can copy that code to the device clipboard and paste it in and automate that flow end-to-end seamlessly as if it was a native experience. And this is something that has been historically not possible with other testing tools, but with Mobot, because we're taking a black box approach to testing, this has enabled us to actually automate things that traditionally engineering teams have had to cover manually. And so here's another example. We're now launching the native share sheet. We're sending a referral link, and on a different device, what we would do is that we would then, Sandra, if you could switch back to my slides, thank you. What we would do is then on a different robot device, we would be able to go through and complete that test with the referral link as well. And so in conclusion, what we're really doing here is we think that there's a time and place for unit tests, a time and place for integration tests, a time and place for doing UI tests that are automated with existing testing frameworks. But there is a tremendous opportunity to really be thoughtful about designing manual testing cases that actually reflect how real humans are using the app in 2022. And so we should really just be rethinking the way that these test cases are designed. It shouldn't just be whatever's the easiest or fastest to test while the app is foregrounded. We really need to be encompassing all the different entry and exit points using other third-party applications. Is someone navigating to your application from an Instagram or a TikTok ad? Is someone navigating via a deep link from a text message? What are the most highest traffic devices and versions that are being tested? Are you actually covering all of those devices when you do regression testing? And how do you actually make sure that those features are all being covered in the same way that users are going to be using? So an example is like going back to that demo video, there are so many ways to enter a two-factor authentication code. Sometimes it's pasting from the clipboard. Sometimes it's individually entering numbers into the keypad. It can be important to observe your users and make sure that you really understand all of those different test cases and designing automation tools and strategies accordingly. Especially also interesting is being able to actually listen to customer support requests and use that as an opportunity to design further regression test cases that are realistic. And so it becomes this sort of feedback loop where you can observe, okay, this is what an App Store review said about the app, and I can turn that into a regression test case that then runs on either the testing framework or on a robot, and really focusing on the scenarios that drive user acquisition, conversion, and monetization the most. And so at Mobot, we're excited to really continue to experiment with modern iOS and Android engineering teams that are on the cutting edge of really just trying to focus on building out this holistic, comprehensive QA strategy. We really think that the right strategy involves a number of different tools. You should be doing device lab testing with emulators. You should also be using virtualized cloud devices if available. You should also be doing some manual testing, but there's also an opportunity here to automate physical real-world test cases that have never been automated before. And so would love to have the chance to connect with anyone who's interested in learning more, or anyone else who has ideas around this space, just to see what are the areas that can continue to be improved. And if you'd potentially be interested in checking out Mobot as well, would love to have a chance to connect with you. Also going to open it up to some questions and see if there's anything that I can help clarify. Thank you. So I see that there is a question from the chat about how to scale in terms of resourcing time and money and balancing using mechanical robots. So one of the important things that we've really observed is that you're not going to be able to test everything, right? Like, being realistic, these are tests that are run on real physical devices. And so that's why we really think that there are all of the tests that should be kind of run on automation tools before something is tested by Mobot. And then Mobot can then focus on the business critical use cases, the test cases that can't be covered by other tools, the test cases that are giving manual regression testing teams the most burden. That's really what you want to focus on optimizing. And we shouldn't just be testing every device under the sun. We should be kind of using analytics, dashboards, for example, if you have App Store Connect or Firebase data or Google Play Beta data about the most recently and frequently used devices and OS versions, Mobot should be used in a way that allows to scale that effectively, not just kind of randomly testing on all the different devices that are available. And so it's important as a part of that strategic piece to really think very carefully about the kinds of test cases that are being run. Like, the premise here is not to have the robot like tap 46 times on the profile page, right? No one would actually do that. The robot is intended to actually go through realistic flows, highly trafficked areas of the application. And that's what helps to keep costs manageable, is because we're trying to augment an existing solution of manual testing that's already being done by a lot of teams, but we are trying to make that more efficient. We're trying to do those tests more efficiently and quickly, and we are also parallelizing those tests across different robots and devices so that all the tests can be run in a more effective way. I see that there's a question around, do we build the robots ourselves? Yes, we do. So Mobot also, we looked at all the different tools on the market. You can buy other robots out there. Using robots to automate mobile app testing is not the original idea. What the original idea around Mobot is that we are doing this as a service, and we found a way to scale this efficiently so that we can essentially use our own robots to then automate testing as a service. And so long term, we're trying to build infrastructure where anyone could connect to Mobot and be able to control a robot live, sort of the way that you can connect to a cloud device right now, and you can do manual testing on a cloud device in a device farm. And so long term, that's the vision that we're building. But in order to kind of make this cost effective and scalable, Mobot does build our own robots. And I'm mindful of the fact that we are running low on time here. So I wanted to thank everyone for all the great feedback and questions. I would love to have a chance to connect with you further on the community site, and wanted to say thank you to Bitrise and the Mobile DevOps Summit for hosting me and the Mobot and giving us this opportunity to share. If you'd like to learn more about our company, please do reach out and check us out. We'd love to give you a demo. And also, if you're just broadly interested in talking more about holistic, realistic test cases and building that test coverage for your iOS or Android app, would love to get that feedback from you guys as well. Thank you so much.